Hello. For this lesson, we're going to talk in this accent. Just kidding. For 3.1 day 2, we are going to solve systems of linear equations algebraically. So this again should feel like review because you have seen this before. It just probably has been a little while. So I'm going to refresh your brain. We have two methods we're going to look at. And the first one is called substitution. And this one can get a bit tricky if you're not really paying attention to what you're doing. So if you've got a highlighter, actually two different colors, that would be even better for this whole lesson. But even if you've just got maybe a different colored pen, make sure you've got a pencil though too, because we need to erase if we make a mistake. But what we're going to do is solve one equation for one variable. Then we're going to substitute what we found into the other equation to find the second one. And we get to be lazy and think about which one would be the easiest to plug it back into so that we can get the second one pretty quick. That's the part we tend to forget about. So the steps are over here on the left. And the first thing we want to do, again, is to solve one equation for a variable like x or y. Sometimes just depends on whichever one you can see as being the easiest. Now I see that this is already set up for y equals a number. So that's going to help me because I already know that y equals this. And I have a y down here. So what I'm going to do is I'm going to replace this y with what y equals. Okay? So that second equation, I'm going to rewrite it as x plus, and then I'm going to leave a space, equals 8. So what are we replacing the y with? Well, we're replacing it with an x plus 2. So let's fill in that x plus 2. That's kind of the trickiest part. Now we're going to go ahead and combine any like terms and solve. X and x added together is 2x. Plus 2 equals 8. And now we can just go ahead and solve this like a two-step equation. 2x is going to equal 6, which means with division we would get x equals 3. Now we're not quite done, and that's where we tend to think we are. If x equals 3, perfect, we found 1. Now we're going to substitute the found answer into the equation up here, and really technically it's the lazy part. How can I get y? Well, up here it says y equals. So let's go ahead and use that one for finding y. Y equals x plus 2. Well, we know what x is. X is 3. So it's 3 plus 2, and y is 5. So that didn't take too long. Now we write our final answer as an ordered pair, like x comma y. So x comes first, then y, with parentheses around them. Now you're done. So that wasn't too bad. What if we have like number 2, where it's not set up to have y equals or x equals something? Well, we can make it that way, can't we? So up here I see y is almost alone. I would just need to get this to the other side. And I could do that by subtracting 2x. So when I subtract 2x, I get y equals negative 2x plus 6. That's going to be the same thing as that top equation. But now I know what y is going to equal. And I can repeat my steps of saying if y is this, then I'm going to replace in the second equation, and we always use both equations, so we can't replace this into the same equation. That wouldn't make sense. So let's go ahead and take this stuff that equals y and replace it with our y here. So y is the same as negative 2x plus 6. So negative 2x plus 6, and then minus 8x equals 1. So we just replaced y with our negative 2x plus 6. Now let's simplify and solve. Negative 2x and negative 8x combining like terms since they're on the same side. And solving. Subtract 6. And we get negative 5 and divide by negative 10. And this one is going to get us a fraction of 1/2. So 1/2 is x, but we're not done yet, right? We need an ordered pair. We need the y. So we can either use this equation up here or any one of these two would work fine. Y equals -2 times x plus 6. Well, what was x again? 1/2. So we're plugging in the value that we found, making sure we plug it in for the correct variable, and then simplifying or solving. So 1/2 of 2 is 1, -1 in this case, and then add 6, so that would be y equals 5. And how do we write our final answer? Yes, you said ordered pair. You're correct. It's like Dora the Explorer. You have to say it to the TV or to the video. All right, I want you to try one on your own. I'm going to get you started with the first step, and that is going to be to get some variable alone. And I see that y is almost alone here, so add x to finish getting it alone. So this would be y equals x plus 4. So now that you have a y by itself, and it doesn't always have to be y, it just happens to be that way on these first few, you're going to replace the y in the other equation with x plus 4. So go ahead and try that, pause, and check when you're ready. So you should have 9 equals -3 parenthesis x plus 4. Again, when we're replacing, it does help to put those parentheses in there, especially when there's a number in front of the variable and you're replacing that with an expression here. Then you should have distributed and then combine like terms and then add 12 and then divide by -7 and you get x equals -3. Then you should have replaced that into one of the equations up above and gotten y equals 1. So your ordered pair should be for number 3, -3, 1 for your solution. Go ahead and try number 4 on your own. You already have x alone. You know that it's y. So replace that y up above with a -2 and check when you're ready. All right, so you should have replaced it, simplified, 4x equals 12, divide by 4 to get x equals 3. And do you need to plug it back in? No, because you already have y equals -2, so you already know what y is. All right, let's take a look at our next method. And our next method is elimination. Elimination is my favorite, where you get to arrange equations so they're stacked, almost kind of like adding and subtracting. You did it in elementary school. And then you're going to create a pair of opposites by multiplying one or both equations. So in this case, this one, when we stacked it, we saw we could get the y's to cancel if this was a +3. So if we take -3 times -y, that would get us +3y. We don't do anything to this one, just the second one, because that way they could match up, and when we add them, they would cancel. We just want one of them to cancel, so we don't have to try and make it work for both. Just one variable that we can figure out how to make it its opposite. So then we continue to add vertically, and then we solve. We get x is 1, and we substitute it back in to one of the equations up above, just like we did on our method 1, to solve for our second variable. And then our final answer we write, just like we did up above, as an ordered pair, 1, 4 for this one. So let's go ahead and try it on our own. So on the next page, flip over, and let's see what could match up. So again, we're looking for the easiest thing. So x and x here, could we get those to cancel if it's 3 and 5? Oh, not really. We'd have to multiply both equations. 5y, could we get this to be a +5y so that it could cancel with a -5? Yeah. We would have to multiply this equation by a 5, and to get this to become positive, we would need to make it a -5 that we were multiplying by. So what I'm going to do first is rewrite my top equation and leave it alone. And then my second equation, I'm going to go ahead and distribute that negative 5 to every single term. So it's going to be negative 25x positive 5y equals negative 95. So we're basically just distributing this negative 5 to every single term there. Now we can go ahead and see that our 5y and our negative 5y add together and cancel to get 0. So now let's add the rest vertically. We get negative 22x equals negative 88. And to finish solving, divide by negative 22, so x equals 4. And that gives us our first variable to now be able to plug back in. And I like to pick the one that's got the smaller variables. It doesn't really matter which one you choose. I'm going to do that top one. So 3 times 4, because I'm going to replace the x, minus 5y equals 7. So don't forget that you're replacing just the x, and make sure you actually plug it in for the x. So 12 minus 5y equals 7, and finish solving. Negative 5y equals, that would be negative 5, and divide, and y equals 1. So we write our final answer as an ordered pair, 4 for x and 1 for y. Great job. All right, this next one is ready for you to cancel the 3's already. You don't have to multiply either equation in this one. So go ahead and cancel those 3's, add vertically, solve, and plug it back in. Check when you're ready. All right, check your answer for number 2. Pause if you need a little more time to look that through, but you should have 5, 8. All right, go ahead and continue and try number 3 on your own. This one you're going to have to multiply both equations. So in order to get this one and maybe this one, I always like to look at the smaller numbers. We could get them both to become a 6 and one of them to be a negative. So maybe up here multiply by negative 3 and down here multiply by 2. That way when we distribute we'd get a negative 6x and we get a positive 6x on the bottom, and that would cancel. So go ahead and multiply or distribute that and then solve and check your answer when you're ready. All right, so check your answer that you distributed correctly, and then canceling the x's, solving for y, plugging it back in, and getting your x. So pause if you need a little more time to check through that work. And we're going to work number 4 together to finish up this section. So the first thing I'm going to do on number 4 is I'm going to get everything lined up. Now I like to have my x's and y's on the same side just like they have been. So let's get this x to the other side by subtracting. Sorry, this y. So we've got a 2x minus y equals 15. And then to get x and y, well, they're already on the same side. Let's just get this 15 to the other side. So I've got a 3x minus 9y equals 15. So now let's look to see what could cancel. Well, I have a negative 9y, and I could make this a positive 9y by multiplying by negative 9. So that way, we can have negative 18x plus 9y equals, what would that be? 9 times, negative 9 times 15 is 135. All right, and then we're going to rewrite our second equation here, the one we didn't change anything on, which would be 3x minus 9y equals 15. All right, so now those y's are going to cancel. We're going to combine vertically, and that's going to give me negative 120. Divide by negative 15. Oops, just negative 15. And x is going to equal 8. All right, we're going to plug in 8 for x. All right, so here is it plugged in. Get 8, 1. and we're going to go ahead and take a look at this last section in class together. So make sure to write any questions that you have over the last two topics, and we'll be sure to answer those and go over these last two things.